So in this section, we're going to talk about the graphing of exponential equations or exponential functions. Okay, depending on our perspective, right? And so before we do that, I want to emphasize what we're going to talk about first, and where we're going to go on to, and what is an exponential equation or a function in the first place. Okay, so for example, an exponential function, the most basic case will be something like f of x equals to b to the x power, where b is some positive number. Okay, and so this would be like the function perspective, where I'm saying that the f is some function that takes an x as an input and that sets some constant b, some positive constant b, to the x power. Okay, this will be an exponential function, and an exponential equation will be something like y equals to b to the x. Okay, again, under the same condition that b is greater than 0. Okay, we're going to examine some simple cases like this first to establish some intuitive ideas about how exponential functions behave um, before we talk about the more general case. Now, you will notice in the first 4 examples, I'm going to use some very nice numbers, which will enable us to make explicit tables and stuff that will bolster our discussion, our intuitive discussion. But all the things we're gonna learn are gonna carry over directly to like the cases where the exponential will be in terms of the special Euler number E. By the way, you don't have to know that it's called the Euler number, but basically the special base E. So for example, there's a very special base called E that is used a lot of it in exponentials, and so everything we're going to learn in the next 2 lectures will be applicable to exponentials with the base E, and we'll do some of those examples later on. Okay, and then of course you could also look at it from the equation perspective of y equals e to the x. Okay, so I want to make sure that you guys know what I'm talking about when I'm comparing between when I say an exponential function or when I say an exponential equation. I want you to know that really it's just a difference of perspective. Remember that when I talk about an equation perspective, I'm thinking about it from an algebraic point of view of the graph being a set of points that makes the equation true. And so I can look at this equation as a statement of I want to select out all those points that make this equation true. Whereas in the function perspective, I might be, for example, thinking of the number of bacteria in a petri dish at a given time. Let's say something like this. My time might be given as the input x, and the f might output the number of bacteria at that time. Okay? And so I can look at it, how many bacteria do I have at time 10? Well, I'll calculate f of 10. It will equal b to the 10th power. Okay? Now, of course, I'm oversimplifying here, just to give some idea of like the kind of very subtle difference in perspective of exponential functions and exponential equations, but the math is the same, the graphs are going to be the same, and but I want you to know, if I say exponential equation or exponential function, I don't want you to be confused by that, and I don't want you to think that I'm saying something that's like fundamentally different, but I want to say that up front so that we don't like make too big of a rigmarole about it. Now, once we've looked at some basic cases, okay, so we're going to look at some basic cases first to develop some insight, okay? But afterwards, we'll be able to look at examples that are more interesting, or not more interesting, but things like f of x equals to, let's say, 2e, we're not going to deal with e yet, but let's say 2 times 3 to the x power minus 4, for example. Or f of x equals negative 4e to the 2x minus 3 plus 7. Okay, or even things, or like things like y equals negative 3 open parentheses 4 to the 3x plus 1 minus 5. See, these are more complicated exponential equations and exponential functions, and we're going to graph those exponential functions or equations, depending on what the case may be, later on once we've developed some insight. Okay, because the having developed the insight first will guide us to do this more effectively. And now I will comment the following fact. Now something like y equals, let's say, negative 2e, well, not that, but negative 2 times 3 to the x power plus x squared, that's no longer purely an exponential function. So this is like more complicated, and we're not going to discuss this example within this section. But later on we might look at examples like this, uh, using some of the insight derived from the section to guide us, but knowing that we're going to have to do some special particular analysis to it, because we know it's not going to behave exactly as an exponential, and it's also not going to behave exactly as a polynomial, right? So it'll have some characteristics that we're going to have to determine on an individual type basis, okay? But like all of these, which are just purely exponential, will behave just as the examples here, and we'll be able to, and we'll discuss those in full detail, okay? Now, without further ado, let's begin.